Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome to this Microsoft Azure Virtual Training Day, Well-Architected Framework. My name is Dr. Kai Dupuy, and I'm an Azure Technical Trainer at Microsoft. This course covers 6 modules, starting with a well-architected overview. In Module 2, we look at the security pillar, followed by Module 3, where you'll learn about the performance efficiency pillar. In Module 4, we'll look at operational excellence, and in Module 5, we touch on the reliability pillar. Finally, we'll wrap up with Module 6, cost optimizations. In this module, we reviewed the Azure Well-Architected Framework, the Advisor Secure Score, as well as the Azure Well-Architected Framework Evaluation Tool. The Microsoft Well-Architected Framework. This is an overview. What we'll cover today in terms of the Well-Architected Framework is why should you care? Why is being well-architected important for your workloads? We'll look at an overview of the Microsoft Well-Architected Framework. We'll also look at some of the inhibitors to quality as it relates to your workloads. How to get started, we'll do a demonstration of the Well-Architected Framework as well as review the Azure Advisor. And at the end of it, we'll give you some resources you can use to get you started. Data breaches, this is a big deal when it comes to building your workloads. A lot of money involved here if your framework or if your solution is not well architected. Data breaches can have a real dollar impact for your organization, and it can also affect your customers as well. Look at some of these numbers here we have as it relates to data breaches and how they cost you and your customers. Customer PII, that's the most frequently and costliest compromised type of record per the latest data breach studies. These are some huge numbers, 3.86 million. That's the average total cost of a data breach. The number of breaches carried out with customer PII, 80%. $150, that's the customer PII average cost per record. Increased cost per record of customer PII and breaches caused by a malicious attack, $175, and $137,000 plus remote workforce impact on average total cost of data breaches. The Well-Architected Framework guides you in designing your workloads in such a way to help you prevent data breaches. What can you do? What can your organizations do proactively to help avoid costly pitfalls like increased spend, like loss of trust, and the costly aftermath of breaches? What you want to do is you want to run a well-architected cloud workload to create value. And so what we're going to be talking about is how you can create your workloads and keep those workloads in alignment with the well-architected framework. What you want to do is you want to invest in these kinds of actions, right? You want to manage your budget. You want to improve your workload security. You want to increase incident response. You want to streamline internal processes. We'll talk about some of the ways you can automate and streamline internal processes. You want to find mistakes where you have cost overruns, or you want to find the areas in which you provision resources that are costing you more money than you need to spend. And you want to make sure that your workloads are performing optimally. You want to enhance workload performance. Why? To avoid these consequences, expenses, and losses, to maintain trust, and to limit damages. It is absolutely critical for an organization to avoid or minimize impact of not running well-architected workloads. So by managing and understanding your budget, you can avoid surprises in the invoice. By establishing processes that drive efficiencies, designing workload architectures to avoid costly mistakes down the road, and making sure these are secured and the data is protected, and having proper incident response plans that allow faster, more efficient reaction to failure. which is going to happen. Let's face it. We don't say that we are designing our workloads so that they won't fail. We're designing our workloads so they can respond to failure in a way that is seamless to your customers. We're going to create your workload so that the organization can minimize or avoid incurring expenses and revenue losses that negatively impact their workloads and their customers. So the well-architected framework enables you to achieve these things. You want to be able to build your workloads with confidence, design your workloads using actionable and simple to use, deep technical guidance of improvement, and where to focus your optimization efforts. You want to perform gap analysis to identify areas of improvement and where to focus your optimization areas as well. So looking at building your workloads with confidence with proven best practices, the well-architected framework can help you with this. Design performing workloads using the deep technical guidance that the well-architected framework provides. Optimizing your workloads, giving you actionable steps that you can take to make sure you're running your workloads in an optimal fashion. Across the board, building optimized workloads is a shared responsibility between the cloud provider and the customer. So here's an example. Here's a diagram of the well-architected framework, which allows you and helps you to build and manage high-performing workloads. With the well-architected framework, by using this framework, you can build workloads with confidence based on these proven deep technical guidelines that you can use to take action and to identify areas of improvement in your workload. So the well-architected framework, as you can see, it sits at the center of an ecosystem of best practices, assessments, documentation, support from partners, reference architectures, as well as design principles. The well-architected framework enables you to achieve your business objectives by operationalizing how to build, design, and optimize your cloud solutions. In terms of the well-architected review, this provides and evaluates your workloads with gap analysis, and it identifies areas of where to focus your optimization efforts. The reference architectures helps you to build and deploy any workload to scale and meet your business needs. You also get an opportunity to follow design principles that are baked into the well-architected framework based on proven practices and design patterns from successful customer and partner implementations. And then Microsoft Partners and Service offers support you and help you build effective cloud solutions. So what exactly does the framework enable in terms of building well-architected workloads? With the well-architected workload, building a well-architected workload being a shared responsibility, Microsoft enables platform capabilities and features, but the customer must build well-architected workloads by making proper use of these capabilities. So many of our services have these capabilities built into them, but they must be turned on, they must be configured, they must be set up. And that's the customer's responsibility. And so if you can look here on the diagram, you see at the very bottom the platform foundation. Core capabilities built into the Azure platform, and that's how the foundation is designed, operated, and monitored. On top of the platform foundation, we have platform features, where you can use optional Azure capabilities that a customer can enable to ensure security, reliability, operability, and performance. And then at the very top, the customer application, that's your customer app or your workload that's built on the Azure platform. So Azure's hybrid model with a unified operational management control processes and governance management offers multiple solutions, enabling customers to confidently deliver hybrid workloads. We provide customers with the controls, the methods, and the tools that support them in building well-architected frameworks. And the customer brings a deep understanding of what they want to accomplish, their goals and constraints, as well as requirements, along with knowledge specific to their industry and their problem domain. So let's look at what you must make trade-offs as it regards to your business context. Do you have to make trade-offs in an enterprise context? And what trade-off decisions must you make in a business context? You have to balance your business requirements and how they influence decisions about how you architect your workload. So for example, development workloads. Optimizing cost in development workloads may be the right approach, even when it may impact reliability, if it's in line with the business expectations. On the other hand, mission critical workloads, where you're looking to improve performance for a mission critical workload, that may be the right business decision, even at the expense of increased cost. Securing all workloads. There's been a surge in cyber attacks that drive workload security investments as organizations attempt to protect their most valuable asset, their data. So there's a balance that you're going to play between your business requirements and architecting for security or architecting for reliability or architecting for performance. Let's walk through how to overcome some of these workload quality inhibitors. There are several factors that can affect overall workload quality. Here are some quality inhibitors to look out for that can be addressed by framework guidelines. Let's look at cost optimization. A couple of the bullet items here. No cost and usage monitoring. That's not a good thing. Unclear or underused orphan resources. Lack of structured billing and management. These are places where cost can get away from you. Let's move to one of the other pillars of the framework, operational excellence. Maybe you don't have rapid issue identification set up, or no visibility on root cause for events, or no communication mechanism, but no deployment automation. Automating is a core tenet of setting up a well-architected framework. So automation is key, and it's something that you want to make sure you're utilizing as much as you possibly can for deployment automation. Performance efficiency. No monitoring of new services, no monitoring of current workloads' health, lack of rigor and guidance for technology and architecture selection. You want to put some thought into how you're choosing particular services to use in your workload and how you're architecting those solutions. What about reliability? Unclear on resiliency capabilities for improved architecture design, lack of data backup practices. This leaves you vulnerable. You want to plan for business continuity in a way that your application or your solutions can remain reliable, have backups, have redundancy, have an idea of what's going on in terms of the health of your workload. You absolutely want to have a plan for disaster recovery. And then as we get to security, no access control mechanism, no security threat detection mechanism. These are all important in terms of making sure you're deploying a secure workload, no encryption process. These are some of the ways that quality is inhibited in your workload. And the well-architected framework gives you the guidelines and the rubric to make sure that you are considering these pillars as part of your workload: cost optimization, operational excellence, performance efficiency, reliability, and finally, security. Best practices to drive workload quality. Again, we look at these 5 pillars: cost optimization, operational excellence, performance efficiency, reliability, and security. You want to implement best practices to continuously drive quality improvements across your workloads. This is not something that takes place once. It's an ongoing process for continual improvement. So let's look at some of the best practices here that would improve overall quality that can be addressed by the framework guidelines. Under cost optimization, you might want to take advantage of existing licenses with the Azure hybrid benefit model. You may want to look at reserved instances, right? You have several pricing models for purchasing virtual machines. You can actually purchase some virtual machines in advance as you know what your workload or your baseline that you need for your solution. By purchasing reserved instances, you commit to a 1 or 3 year period, but you get a discount on your hourly rate on those instances. You want to be able to resize your instances, make sure you have the right size. You want to right size your instances to make sure you've chosen a size that's not too big or not too small, so you aren't overspending or providing too few capacity that will give your users a negative experience. Under operational excellence, we want to look at DevOps practices, absolutely, and break down those silos between development and operations and automate our delivery mechanism. Look at a CI/CD pipeline setup. And deployment monitor, right? We can be able to monitor our deployments and make sure that the posture that we've taken from a security and an operational standpoint is being maintained. What about efficiencies for performance? We want to absolutely make sure we're designing for scaling, right? We're designing in such a way that our workloads can adjust to changes in traffic, right? We want our workloads to be dynamic. We set up our workloads, and all of a sudden there's a media event, or there's perhaps something happened in the news that brings more traffic to our website. We want our website to be able to expand. We want it to be able to scale to handle that demand, as well as scale back in or shrink back in when that peak moment has occurred and ended. And reliability. We absolutely want to define requirements. We want to test with simulations and force failovers. We want to know what will happen in the case of a failover. We want to make sure that what we've set up in terms of mitigating an issue or some component of our application going down, that we can handle that we have a failover process in place. We need to test that failover process. We need to be able to deploy our environments consistently as well. This allows us to have a more reliable environment. And from a security perspective, we absolutely want to make sure we're dealing with identity and access management, application security, and we want to look at some of the services available to you in Azure from a security operations standpoint. Services like Azure Security Center and Sentinel. So how do we get started optimizing existing workloads and designing and deploying new workloads? How do you get started? Microsoft has several tools that you can use to optimize the quality of deployed workloads and align that quality across new workload designs and deployments as well. There are many tools and technical guidance that we can provide for you in several categories. In terms of optimizing existing workloads and designing and deploying for new workloads, here are some of the tools you can use for optimizing existing workloads. You can look at opportunities and recommendations to improve your workload by using a service called Azure Advisor. And the Azure Advisor will generate an Azure Advisor score. Azure Advisor is a recommendation engine. And so it will analyze your workload and report back what you can do in terms of improving the quality of your workload as it compares it to the guidelines given to you by the Azure well-architected framework. You can understand any changes or look at what's happened in past incidences. You can review technical guidance of the well-architected framework. And as always, you're considering the trade-offs to achieve your business goals from an architecture perspective. You also want to define and implement technical recommendations and implement workload optimizations on a regular cadence. So as I mentioned before, this is not a one-time activity. You're going to be doing this as an ongoing process. In terms of designing and deploying new workloads, you want to look at your workload architectures and map those across business priorities. You want to also still look at a review from a technical standpoint, comparing what you've built to the well-architected framework. You want to assess the well-architected framework design by utilizing the well-architected review. The well-architected review is a rubric that we provide you with that you can point to a solution or a workload, and it will ask you questions, right? You answer those questions, and then it generates feedback. It generates recommendations comparing what you've answered in terms of what should be done against that workload. You want to consider your architecture design trade-offs to achieve your business goals just like you would with an existing workload that you're optimizing. And you want to make sure that you build and deploy and manage well-architected, optimized workloads on Azure. This is the whole point of the process. Let's walk through this workload optimization process. So in the workload optimization process, the first thing we're going to do is we're going to gather and analyze data to identify and confirm optimization opportunities. Then we're going to review recommendations on which opportunities to pursue. Then implement those recommended optimizations and set up reviews going forward. So we're going to collect data to identify optimization opportunities. We can do that with the well-architected review. And as we gather this data, we're going to analyze it to confirm what opportunities we want to act on. Then we're going to create a plan to utilize those recommendations to optimize our workloads. And then we're going to implement those recommendations in a continuous cycle. We'll continue to collect data and continue to identify optimization opportunities and continue in this cycle of analyzing, advising, and implementing. So the well-architected review. Utilizing the Microsoft Azure well-architected review, It is basically an assessment tool. It's a web-based assessment tool that we have built to help you evaluate the quality of your workloads across the 5 pillars that we've identified from the Azure Well-Architected Framework. It has a series of questions across those 5 pillars of the Well-Architected Framework and responses to the questions, and evaluates key items needing attention for a successful workload deployment and management. Now, the results of the assessment gives you actionable steps to consider implementing to improve the quality of the workload. That's going to help you overcome your hurdles effectively and build your workload with confidence. It also allows you to choose only one pillar or more, depending on where you want to focus. If you choose more than one, you get gauged results for each pillar, helping you to focus on the areas your workload needs more attention, perhaps reliability or security. The assessment will typically require about 20 to 25 minutes to complete if you choose all 5 pillars. We can review and run the assessment together, or you could choose to take the assessment on your own and share the results with others within your organization or with other representatives or partners. So let's take a look at the assessment in practice. So here's a summary of the Well-Architected Review. Now, as you can see here, it shows us a screenshot here of the Azure Well-Architected Review. It also shows us recommendations of a particular workload. We have moderate recommendations here. It tells us you got a result of 50 out of 100, and it's going to give you recommendations on how you can improve that score from 50 up to 100. If you look at the Azure Well-Architected Review screenshot here, you can see it has, under Azure Well-Architected Review, it says choose your interests. Those interests are one of the 5 pillars. You could do all 5 pillars, or you can just do one of the 5 pillars. You can choose cost optimization, which will look at ways to save money and reduce your spend. You can look at operational excellence to ensure your application is running efficiently and effectively. You can look at the performance efficiency in terms of scalability. You can look at reliability to make sure your application can function or your workload can work in the case of failures. And you can look at security to make your workload more secure running on Azure. You can look at all 5 of these pillars, or you can pick one and you will go through that particular pillar. The Well-Architected Framework will ask you questions. You answer those questions, determining how well you built your workload in terms of how it compares to the framework. All right, now that we have seen what the Well-Architected Framework has to offer, let's jump right in and do a quick demo of its features. Okay, as you can see, it brought me to the Well-Architected Framework page. It shows us right here, before you get started, consider signing in to save your progress. I can tell you from experience, that's something that you want to do. So all I have to do now is click my link, and it brings me here to the Azure Well-Architected Framework Review. The first thing you want to keep in mind as you come into the Well-Architected Review site is what kind of workload it is that you're going to be accessing. Now, there are plenty of different kinds of workloads. If you want to get an idea about those, you can actually go to the Azure Architecture Center, and you can see hundreds of examples of different architectures for workloads. For our purposes here, I'm going to just talk about an infrastructure as a service web application with a relational database. Typically, when you set up a workload such as that, you're going to want to make sure that it's a zonal application. You're going to want to make sure your workload's database, as well as the VMs running the website, have been architected to utilize availability zones. So that's just an example of a workload you might be looking at when you come in here to do the Well-Architected Review. So the very first thing it asked me to do is to sign in to save my progress. I highly recommend that because oftentimes I forget to do that, and I'll go through some steps and I'm not able to save. I actually want to have a checkpoint or a place to come back and see what I did last. So I'm going to go ahead and sign in. Okay, so now I'm logged into the Azure Well-Architected Review site, and I can give my assessment a name here. We'll just leave the default name that is given us. And right here, it shows you that you can sign in with your Azure portal credentials, and that will allow Azure Advisor recommendations to be included in this assessment. We absolutely want that to be the case. So I'm going to go ahead and sign in here. Then I'm going to choose an Azure account, an existing account that I already have. So I'll choose my Microsoft account. And then it's asking me to select the scope of my Azure Advisor recommendations to import. And it's going to give me the option of choosing a subscription and resource groups. So I'll choose my Azure subscription here. And I'm going to leave this as all resource groups. Select import. And so what that's doing is, as I mentioned before, the Azure Advisor is a recommendation engine. And so it's constantly monitoring your workloads to give you recommendations on how to make them more well architected. And so we're going to import those recommendations into the tool. Okay, so now I've got this particular subscription and this particular, in all my resource groups. Now, of course, I can segment my workloads by subscription and by resource groups. And so if I had a particular workload or collection of resources that made up a particular workload, I would have chosen just that resource group, and then I'm going to assess that particular workload. So this may actually include multiple workloads. So down here it says choose your interest. And by choose your interest, it means what are the 5 pillars of the well-architected framework do you want to consider? So I'm going to choose a couple of these here. I'm going to choose cost optimization, and I'm going to choose operational excellence. And if you look over here to the left, you can see under cost optimization is giving you several questions, like 12 or 13 questions here. How are you modeling cost of this workload? How do you govern budgets and application and lifespan for this workload? How are you monitoring costs? How do you optimize the design of this workload? That's under cost. If we look at operational excellence, it has several questions over here as well. Have you identified and planned out the roles and responsibilities to ensure your workloads? What design considerations for operations have you made? And it gives you the overarching question for each one here, right? Under cost, an effective architecture achieves business goals and ROI requirements while keeping costs within the allocated budget. And from an operational excellence standpoint, how do you ensure that your application is running effectively over time? Consider multiple perspectives from both an application and infrastructure angles, and your strategy must include the process that you implement so that your users are getting the right experience. So I'm only going to choose these couple of interests or these 2 pillars, but I could choose them all. And then I'm going to choose next. And now it's going to ask me questions from a cost perspective, followed by a performance perspective, and then an operational perspective. And answering these questions lets the well-architected framework review engine know what I've put in place that matches the best practices. Okay, so are cloud costs being modeled for this workload? I'll say, yeah, we are modeling cloud costs. Is the price model of the workload clear? Nope. Do we have critical system flows through the application that have been identified for all key business scenarios? Nope. Cost implications of each Azure service used by the application are understood. Yeah, I have a good idea. The right operational capabilities are used for Azure services, okay? And then am I using the Azure hybrid use benefit in terms of, you can see the tooltip here, it talks about licenses. Understanding your current spending on licenses can help you drive down costs. So you may be provisioning a virtual machine that you already own a license for a virtual machine. You can utilize that license in the cloud. So this tells me by the fact that I haven't answered all the questions or I haven't checked off all of these that I have work to do. So I'll click next. It's asking me some more questions here. Budgets are assigned to all services in this workload. Sure. And these questions pertain to this overarching question. How do you govern budgets and application lifespan? Does every environment has a target and end date? Yes. Is there a monthly or yearly meeting where the budget is reviewed? Yes. Is budget factored into the building phase? No. Is there a plan to modernize our workload? No. Are Azure tags used? Yes. Okay, so I'm just kind of giving an idea here of some of the things that you may or may not have done when you built your workload or workload that's already been deployed. We'll click next. How are you monitoring cost of this workload? Are alerts set for cost thresholds and limits? No, I didn't know I could do that. Specific owners and processes are defined for each alert type? Absolutely not. Application performance tools and log aggregation technologies are used to collect logs and metrics from Azure resources, sure. And what you imagine if you're building a workload and you type and you select none of the above, right? That's going to give you a lot of recommendations. Cost management tools are being used. Yes, I'll click yes. We click next. And so you see you're just walking through this process of indicating what you have and have not done in terms of architecting your workload. How do you optimize the design of this workload? Right? Do you continue to monitor and optimize the workload by using the right resources and sizes? Was the application built natively for the cloud? No. Is there an availability strategy defined and cost implications of it are understood? Yes. Does this workload benefit from higher density? No. Data is being transferred between regions? No. The workload is designed, no, I'm not doing any of these things, right? This is what we typically run into when folks are new to the cloud. And I can also add a note here, right, on any one of these sections where I was asking questions. Not sure about availability, need more information. Oops, to answer. That's a note to me, right? And I'll click next. How do you ensure that cloud services are appropriately provisioned? Deployment of your cloud resources of a workload is known as provisioning. When you create a resource or provision a resource or instantiate a resource, you're creating something that you're going to start getting billed for, like a virtual machine. Are your performance requirements well defined? Absolutely not. Targets for the time it takes to perform scaled operations are defined and monitored? No. Is the workload designed to scale independently? No. The application has been designed to scale both in and out? No. And this is oftentimes, right, we see this because a lot of times companies or organizations, they just don't know that these capabilities are here. They started using Azure and they have not been through proper training to understand these features. So I will say tools such as Azure Advisor is being used because Azure Advisor comes as part of your Azure subscription. So I'll put that there. Resources are reviewed weekly or bi-weekly for optimization. Yes, we're doing that. Cost-effective regions are considered as part of the deployment selection? No. So typically when you're doing this and you're selecting these options, it's based on what you knew at the time, right? And that's what makes this so important and so powerful. So we'll click next here. What considerations for DevOps practices are you making this workload? So I'll do a couple more here. You can see there are 27 questions just for cost optimization, right? So I do a couple here. There's an automated process to deploy application releases to production. That's CI/CD, DevOps, more than likely no. There's a difference between configuration for production and non-production environments. Absolutely. Test environments are deleted or deployed automatically and deleted after use. We're not doing that. So we'll leave that the way it is here, and I'll click next. Now, I could continue doing this and continue answering the questions. I'm going to leave this for now, and I'm just going to go ahead and click through, meaning we're not doing any of these things or taking any of these actions. And then this brings us to operational excellence. I'll do a couple of these as well. So operational excellence, this is the second pillar, right, of the well-architected framework. Development and operations processes are connected to a service management framework like ISO or ITL. Nope. Is there separation between development and operation teams? You understand how the choices and desired configuration of Azure services are managed? I do not. Okay, so we'll click next. I'll do a couple more here. You have documented any components that are on premises or in another cloud? I have not. You've deployed across multiple regions? No. Application platform components are deployed across multiple active regions? No. All platform level dependencies identified and understood? Okay, we'll say we've done that. We'll click next. And by me clicking next on these other questions here, have you defined key scenarios for your workload and how they relate to operational targets and non-functional requirements? By me not selecting any of these options here, I'm saying I haven't done any of these, right? So I can do none of the above. And I'll do the same here, none of the above. None of the above. And we'll eventually, you can see over here, it's going down each one of these questions. And it's going to take this data and make a recommendation or recommendations. A couple more. And you don't have to go through all of these. I think they might have one more to go. All right, so now we've reached the last question of our operational excellence pillar. What operational excellence allowances for security have you made? Regulatory and governance requirements of this workload are known and well understood? Absolutely. That there are tools and processes in place to grant just-in-time access? Nope. Appropriate emergency access accounts are configured for this workload? Nope. And so now we've answered all the questions, and we can click here on the View Guidance button to get the recommendations that this assessment tool has to offer. And it gives me results, right? View how your workload aligns to best practices and recommendations to help you improve for this subscription and these resource groups. And so if I scroll down a little bit, you can see it says recommendations for your workload. And because I skipped most of those options to those questions, you can see I'm in a critical state or stage. Room to improve. It looks like there are key items needing attention before you're ready for successful cloud employment. You can see my score is 19 out of 100, and you can see that the categories that influenced my results came across the pillars of cost optimization and operational excellence. Okay? Then it gives you next steps, right, that you can take as well. Identify how long the workload can be down for and how much data is susceptible to lose in a disaster. Be aware of your resource limits and automating manual tasks, and it gives you some documentation that you can use to go and do those kinds of things. But if we come back up here, we can also drill down into each one of these. So if I go into the cost optimization, for example, okay, under cost optimization, it gives me 23 recommended actions. Now the other 3 pillars I didn't assess, 20 recommended actions, and I can click here under Show More, and it gives me those actions, right? Links for what I need to do to improve my workload and improve my score, right? Set up a disaster recovery strategy, and I can drill down into that and give me some guidance that'll help me. So if we go back here, under recommendations, I could also click on the answer summary here, right? And shown below are the assessments questions and how they were answered. So you can see how you answered the questions. How are you modeling cloud costs for this workload? How you govern budgets? You can come in here and you can look at what you said, right? And keep that as part of your information as well as you continue to improve. We can also come back here, and if we go back, you can see right here, show all original responses available for each question. I can actually do that as well, all right? So I can see what we put here in terms of our answers to those questions. And if I come back here under guidance, there's one other feature here I wanted to show. Oh, we can also export our recommendations, right? Remember, it's taking answers to those questions, and it's also combining that with the Azure Advisor recommendations. But if I click on Export to CSV, that'll build me an Excel document, and it takes all the recommendations, and I'll just go ahead and open this file and place them in an Excel document. So the Azure Well Architected Review and my overall score, the individual scores for the different pillars, and then different next steps. Okay, so I can share that. I can use it as data input to some other process that I might be running and use that to go a little bit further. One other piece, you can go up here as well and click on Overview. Okay, and once you click on Overview, it gives you the option to create what we call a milestone. And a milestone is like a new point in time when you want to begin reviewing your workload from a different perspective. In other words, you're going to adjust your answers to some of those questions, right? And so I can come here, and you can see what we have is the one that was named Well Architected Review. And I can come in and I can say, I want to do a new milestone. And I can give it a name like Milestone 1, right? Or whatever name that suits your fancy. And I can come down here and I can adjust this, right? I can say, okay, now I want to add the performance efficiency pillar as part of my evaluation or assessment. And I'll click on performance efficiency. And I'll click next. And I can come in here now and I can answer these questions differently. Oh yeah, now the price model of the workflow is clear. And there is a well-understood capacity, right? And if I continue to click next through it, I will be given the option to add that pillar, right? And answer questions about that pillar as well. So I'm not going to go back, and I could also answer other questions here. Like I could say, oh yeah, we now know data is being transferred between regions. So I'm creating a milestone, and it puts a time stamp on it. And it can show me and allow me to compare the original assessment with the milestone that took place on a particular date and how I changed the answers to those questions and how that reflects in my assessment. And so I'm just going through these and changing it just a little bit. And I could go all the way down and go into the operational excellence piece as well. But instead of doing that, I'll go ahead and come over here and do view guidance. You can see it added my milestone here. I can do view guidance. Okay, so I click back on guidance from the milestone. And what you can see here is, even though I didn't go in and answer any other questions for performance efficiency, which I did set that up in the milestone, you can see that cost optimization and operational excellence, although they're still critical, there are more recommended actions, right? There are 30 here and 62, as opposed to how those were lower numbers previously. And if I click here now to cost optimization, you can see now it's 32 out of 100. I think it was 19 the previous time. And now I've got more recommendations. And so the milestone is a way, and I can do the same thing here. The milestone is a way for you to modify your answers to those questions, and it captures a time frame so that you can go back and compare where you were previously in terms of your well-architected framework for your workload and where you are at the point in time that you added the milestone, meaning you've made changes or you've done things so that you can answer those questions differently. Okay, and that's the well-architected framework, a quick walkthrough over how you use it to apply it to your workloads in terms of the 5 pillars, answering those questions, exporting, etc. So you can get an idea of the recommendations, you can get a score, and then you can go back and pick those recommendations and use those recommendations to improve the quality, resiliency, and the architectural soundness of your workload. All right, as promised, I'm now going to share some resources with you that can help you on your journey to architecting and optimizing your workloads for success. Now, first thing I want to say, all of your partner resources, those are going to be available to you in the partner zone. But there are other resources, as you can see here on the slide, that you want to take advantage of. Leverage assessment recommendations, that's the Azure Well Architected Review that we talked about. Also, maybe you want to pursue more training, right? Learn more about Azure, learn more about the resources and services that we offer. There's a well-architected learning path as well on Microsoft Learn. And Microsoft Learn is actually one of my favorite resources for learning all things Azure. You can browse reference architectures. I mentioned this earlier, the Azure Architectures website. There's also a brand new show on Channel 9 called the Azure Enablement Show. You definitely want to check that out. You can review design principles, right? The well-architected design principles documentation, as well as review documentation about the Azure well-architected framework. I recommend reading that documentation before you actually use the assessment tool. If you want to engage your partner, you can look at partner offers again at the partner zone. And then if you need consulting services from Microsoft Consulting Services, you can find them on the MS Consulting Services website. All of these resources used together should position you very well for crafting workloads that are architected in alignment with best practices that we've talked about in the well-architected framework. This concludes Module 1. We will take a quick 10-minute break and start back with Module 2, Security Pillar. We're going to take a look at the Security Pillar. Now, Microsoft's well-architected framework sits at the center of an ecosystem comprised of assessments like the Azure Well-Architected Review, Azure Advisor, which is our service that gives us recommendations, documentation, reference architectures, design principles. It is the Azure Well-Architected framework that we're going to continue to use as we look at the separate pillars that make up crafting a workload that is high quality, highly reliable, and highly performant. Microsoft spends over $1 billion every year on research and development to make sure your organization and enable you to digitally transform without compromising productivity. We do this through our operations, technology, and partnerships. What makes Microsoft so different to other cloud providers and even security providers is that we have intelligence informed by trillions of sources so we can help you make smarter decisions and remediate faster. We provide a truly holistic approach to technology. Microsoft helps you protect identities, data, applications, and devices across on-premises, cloud, and mobile. This protection is at global scale, and you benefit from the investment of security at global scale that is built into the capabilities and resources of our services. Let's look at a custom implementation of using Azure to create and deploy an intelligent, secure, hyperscalable solution in just a few months. So RxR created a system called RxWell, and during design phases, through management and operating in the cloud to optimize workloads, RxR built a comprehensive public health-based data-driven program powered by the IoT and the intelligent edge using Azure to create and deploy an intelligent, secure, hyperscalable solution in just a few months. So RxR Realty, that's the third largest real estate owner in New York City. They have over 25 million square feet of space, including some of the most iconic addresses in Manhattan. When the COVID-19 pandemic hit, RxR needed to integrate new safety measures for tenants after its buildings reopened. The solution is RxWell, a comprehensive public health-based, data-driven program powered by the IoT and the intelligent edge. It's rooted in responsible AI principles. RxR used Azure to create and deploy an intelligent, secure, hyperscalable solution. Let's talk about each principle, starting with building and managing proactively secured workloads. Security provides principles to protect, detect, and respond to threats across your Azure environment. You want to emphasize protection, detection, and response. So, building us upon a secure foundation. We want to look at ways you can design a workload, assuming workload failure. We want to look at ways to proactively stay secure with native controls. And you want to be able to detect and respond to threats. So designing and assuming workload failure with multi-layer protection controls, this is the idea that we want to build our workloads in such a way, not that we don't expect them to fail, we know they're going to fail, right? The idea is that we want to be able to recover gracefully when they fail. Also building workloads with using zero trust principles in both IaaS and platform as a service resources. And of course, embracing Azure security investments, resources, and compliance certifications. Now, in terms of proactively staying secure with native controls, you want to be able to continuously manage your workload security from a single pane of glass. We can do that with our service that's known as Azure Security Center. You want to be able to protect your workloads from malicious attacks. You can do that with a service called Azure Web Application Firewall, which is cloud native, which allows us to protect your web service, your web resources, your web applications from known web attacks. And then you can manage identity and access for your workload with Azure Active Directory. Detect and respond to threats. We have services that help you with that as well. You can leverage large-scale intelligence from decades of Microsoft security experience by utilizing Microsoft's Intelligent Security Graph. You can embrace automation with Azure Defender to get threat protection for your workloads, and you can establish procedures to identify and mitigate threats for your workloads with Azure Sentinel, which allows you to monitor alerts, and you're given alerts in threat protection, threat detection in your environment across your resources in your Azure cloud, on-premises resources, as well as resources that may live in another cloud. Let's talk about the principle of building a comprehensive strategy. So, a security strategy should consider investments in culture, processes, and security controls across all system components. And that strategy should also consider security for the full life cycle of system components, including the supply chain of software, hardware, and services. You have three options here as well, or three pillars, I should say. Protecting your customer data, securing hardware, testing, and monitoring. With regard to protecting your customer data, you can use Azure Active Directory to manage access to your Azure resources using role-based access control and different ways to authenticate through Azure Active Directory. Additionally, we have a service called the Azure Key Vault. You can use Azure Key Vault to store secrets like sensitive data like certificates, connection strings, API keys, tokens. You can also take advantage of the Azure Security Benchmark, which is the default security policy that is set up in the Azure Security Center to allow it to monitor your workloads from a security operations standpoint continuously. You also want to make sure your hardware is secure. Now, Azure is hosted on custom-built hardware with integrated security. Also, the host attestation service that makes sure that machines are trustworthy before they're allowed to interact with customer data. And under testing and monitoring, you absolutely want to be constantly testing your environments, running simulated penetration attacks to detect system vulnerabilities and validate defenses. You want to also take advantage of tools like security data classification and recommendation in Azure SQL Database, for example. You can classify your data, protect your data, and monitor sensitive data assets using access control, encryption, as well as logging. Encryption goes across many of our services that store your data. Logging is available in multiple services as well. And access control, as I mentioned, you can deploy that using role-based access control in your Azure Active Directory tenant. Let's discuss the principle of assuming zero trust. So this principle is assuming zero trust. You want to protect your Azure service resources from the internet by allowing access only to your virtual network. In terms of your virtual network, the kinds of attacks you want to protect against, we have several services that are available to protect against those specific kinds of attacks. We have a DDoS protection service. We have the web application firewall. We have the Azure firewall. We have network security groups, as well as virtual network integration. DDoS protection is a service you can use to set up a DDoS protection plan, and you can allow the DDoS protection plan to monitor your Azure resources that live or house within your virtual network. It can be tuned to your application and traffic patterns. The web application firewall I mentioned a few minutes ago allows you to protect or monitor inbound web application protection from common exploits and vulnerabilities. It can monitor traffic for things like SQL injection and cross-site scripting. Azure Firewall is what we call a protection at the perimeter layer of your workload. It protects inbound and outbound and protects your resources. It allows you to set up rules to determine whether or not you're going to allow traffic inbound to your virtual network or traffic outbound from your virtual network. The Azure Firewall helps you protect you against data exfiltration protection using centralized outbound and inbound network and application filtering at layers 3 through 7. Then we have NSGs and network security groups, where it allows you to set up rules from a network perspective, from a traffic perspective, inbound and outbound network. This is an L3 and L4 layer traffic filtering against virtual machines, subnets, or containers. And our virtual network integration allows us to restrict access to Azure service resources, platform as a service, for example, to only your virtual network. These are used in what we call a defense in-depth strategy, or a protection at security at every layer, so that if one of your layers of your workload has been compromised, there's more security waiting for the attacker at the next layer. So for example, they get past DDoS protection and they try to make contact or connect to your web application. They still have to get past the web application firewall, and then the Azure firewall, and then network security groups, etc. So you want to protect your workload using a defense in depth philosophy. And with that, let's discuss the next principle, leveraging native controls. So Microsoft, as I mentioned, has invested across identity and access, management, applications and data, security, network security, threat protection, and security management. So what we mean by native security controls are controls that are maintained and supported by the service provider, and that eliminates or reduces the effort required to integrate external security tooling and update those integrations over time. And so you look at, as I mentioned, an in-depth defense strategy, and you look at the built-in Azure controls, going from the controls that are available to you from an identity and access standpoint, from an apps and data security standpoint, network security, threat protection, as well as security management. So identity and access management tools, that allows you to take advantage of identity-based approach to security and establish truly conditional access policies. Meaning, you may set up a control to give someone access to a database, a particular table in that database, only if they're utilizing MFA. From an app and data security standpoint, we can help you to protect your apps and your data as it moves around both inside and outside of your organization. Azure includes a robust networking infrastructure with built-in security controls for your application and service. Threat protection capabilities are built in and fully integrated, so you can strengthen both pre-breach protection with deep capabilities across email, collaboration services, and endpoints, including hardware-based protection, and post-breach detection that includes memory and kernel-based protection and response with automation. Security management tools gives you the visibility and, more importantly, the guidance to manage policy centrally. And customers often ask, what do I control? How do I manage my data and secure access to it? These defense in-depth strategies, from identity to the new perimeter of a cloud native, mobile first world to security management, where I want a unified view of my hybrid environment. These tools come from Microsoft and their partners in our ecosystem, expanding the choices for our defense in-depth strategies. Let's explore the next topic, leveraging controls principles, a bit further. So leveraging native controls, go a little bit deeper into it here. We'll talk about Azure Security Center. It's a unified infrastructure security management system. It's built into Azure. It's built into and connected to and integrated with all the resources that you're running on Azure. It allows you to build native security and governance as well as native threat protection into a resilient design with a rich cloud-native Azure tool set. So it strengthens your security by allowing you to set up a posture for your data center and then monitoring or evaluating your digital estate based against that policy. And it provides advanced threat protection across your hybrid workloads as well. So in the cloud, on premises, as well as other clouds. That's the Azure Security Center service. We also have the web application firewall. This gives you centralized protection and inspection of HTTP requests to prevent attacks like SQL injection or cross-site scripting. And then we also have Azure Active Directory. This is Microsoft's cloud-based identity and access management service, which helps your employees securely access resources that you're running in your Azure account. Azure Active Directory provides us with managed identities, which eliminates the need to store credentials that could be leaked. And you can also use Azure AD Connect to synchronize and connect your Azure Active Directory tenants to your on-premises Active Directory directory structures that live on premises. So you can use Microsoft's cloud-based identity service to secure access to your resources. You can use managed identities as a feature of Azure Active Directory, so you can eliminate the need to store credentials. And you can use Azure AD Connect for synchronizing Azure AD with your existing on-premises directories. Detecting and responding to threats. The principle here is designing for resilience. You want to be able to build native security and governance as well as native threat detection into a resilient design for your workload with a rich cloud-native Azure tool set. So most of what you need to do this should be available to you in Azure. So looking at native security and governance, the first thing we want to talk about here is the ASC Secure Score, the Azure Security Center Secure Score. Now, the Secure Score is a score that the Azure Security Center calculates for you, and it measures the level of risk of your workload or of your subscription, of your resources. And it's based on the Azure Security Benchmark that we mentioned previously that's part of the default policy of the Azure Security Center. So Azure Security Center is monitoring your environment against the Azure Security Benchmark, the default policy, and is giving you recommendations based on where your workload sits in terms of how compliant it is to that security policy, default policy. The firewall is going to protect your network. You can control and set up rules for inbound and outbound traffic, what you're going to allow. Web application firewall we talked about. SQL protection as well, right? Your Azure SQL database, your platform as a service resources. You can also use that service, and you can use controls in that service to help you secure your data. There's firewalls that you can use. There are encryption technologies, TDE, transparent data encryption, as well as always encrypted that's also available. And then there are controls you can use to protect your APIs, like API keys to control access to your APIs. And then from a native threat detection perspective, Microsoft Defender, this is now the name that we call for our enhanced security around several of our products that's been integrated into Azure Security Center. And you can see how it encompasses here Microsoft 365 Defender as well as Azure Defender. And under Azure Defender, we have different categories of resources that it allows us to protect. Our SQL databases, virtual machines, containers, IoT hubs, network traffic, as well as applications. And then our security and incident and event management tool, Azure Sentinel, this is our threat detection tool, right? This tool allows you to collect data or use data from multiple clouds, from Azure, from other clouds, from on-premises, as well as third parties and partners. All of this data comes into one place and allows you to respond to detection of threats, incidents, as well as allow you to do hunting and look for possible issues before they've even happened. So Azure Sentinel is cloud native. It gives you intelligent security analytics for your entire enterprises. It has what we call data connectors. It allows you to connect any of your security sources using these connectors and industry standards, and then take advantage of machine learning to correlate those multiple low fidelity signals spanning multiple sources to create a comprehensive and complete view of a kill chain, prioritize alerts so that defenders can accelerate their time to evict adversaries. So you use these together. Everything here is part of what we offer on Azure, and this can become part of your designing for resilience in terms of your workload. Now, of course, security is one of the most important aspects of any architecture. It provides confidentiality, integrity, and availability, assurances against deliberate attacks, as well as abuse of valuable data and systems. You don't want to lose these assurances. Losing these assurances can negatively impact your business operations and revenue, as well as losing your organization's reputation in the marketplace. So your account control strategy should rely on your identity systems for controlling access rather than relying on network controls or the direct use of cryptographic keys. So RBAC, Azure Role-Based Access Control, provides the separation when accessing resources that an application uses. You can decide who has access to the resources at a very granular level and what they can do with those resources, right? Authentication versus authorizations. You can grant roles you can grant roles that have the permissions to the appropriate people, the users or applications or services that start with least privilege. So you give them the roles based on least privilege, but they need to get their job done. And you add more on your operational needs. This allows you to provide clear guidance to your technical teams that implements permissions. Having this level of clarity makes it very easy to detect and correct that reduces human errors such as over-permissioning. We like to recommend that you require two-step verification for all of your users. This would include administrators and others in your organization who can have a significant impact if their account is compromised, for example, financial officers. So an defense in-depth approach or security at every layer approach can further mitigate risk, including supplemental controls that protect the endpoint if the primary traffic controls fail. You can use native Azure networking features to restrict access to individual application services, explore multiple levels such as IP filtering or firewall rules to prevent application services from being accessed by unauthorized actors. Let's look at what security looks like in the context of the well-architected review. So the well-architected review, the well-architected review provides technical guidance using directed questions to assess your workload security capabilities and offer guidance for the next steps of improving your workload's quality. So just as we saw in the overview, here we're going to look at a particular pillar, right? And we would choose security. You can see here that there are several questions here that you can choose from, right? Well, actually, here you see the pillars: cost optimization, operational excellence, performance efficiency, reliability, and security. We're going to use the well-architected review and look at the security pillar. So let's look at security questions in detail. I've selected 3 of these questions to walk you through during the session to show how it's done, what's needed to answer them, and to get the right guidance. Let's walk through each of these questions. There are 13 questions in security, and all of them are important. We're just choosing a sample here for your reference. At any point, you may click on View Guidance, and that will bring you to the report with the recommendations and guidance based on your responses and the information imported from Azure Advisor. So we've got, have you done a threat analysis of your workload? How is security validated, and how do you handle incident response when breach happens? And are keys, secrets, and certificates managed in a secure way? Let's look at each of the questions. Modeling and analyzing threats is critical to try to prevent and react to security threats that could potentially target your workloads. Adopting a threat modeling process can prevent negative impact on business operations and revenue. In your analysis, prioritize your security requirements. Then include processes and short timelines for fixing security threats that don't meet requirements. Timeliness helps in staying secure and preventing new unauthorized access. Remember to share your strategy with stakeholders. It's common for organizations to have a large application portfolio. Have you identified and classified key business applications? This should include applications that have a high business impact if affected. Examples would be business critical data, regulated data, or business critical availability. It's also recommended to use an industry standard benchmark as the Center for Internet Security or MITRE ATT&CK framework. Benchmarking lets you know how your current security state compares to that of other organizations. Threat modeling is an engineering technique which can be used to help identify threats, attacks, vulnerabilities, and countermeasures that could affect an application. Threat analysis consists of defining security requirements, identifying threats, mitigating threats, validating threat mitigation. All of these are needed to ensure proper security of a workload on both the prevention and reaction fronts. Threat modeling processes are adopted. Identified threats are ranked based on organizational impact, mapped to mitigations, and communicated to stakeholders. Microsoft uses Stride for threat modeling. Tools like Microsoft Threat Modeling Tool can also help. There's a process to track, triage, and address security threats in the application development cycle. The threat modeling tool will produce a report of all the threats identified. This report is typically uploaded into a tracking tool or work items that can be validated and addressed by the developers. Cybersecurity teams can also use the report to determine attack vectors during a penetration test. As new features are added to the solution, the threat model should be updated and integrated into the code management process. If a security issue is found, there should be a process to triage the issue in the next release cycle or a faster release depending on the severity. Timelines and processes are established to deploy mitigations, security fixes for identified threats. Fixing identified vulnerabilities in a timely manner helps staying secure and preventing additional attack vectors. Security requirements are defined for this workload. Azure resources should be blocked that do not meet the proper security requirements defined during service enablement. Threat protection was addressed for this workload. Enterprise workloads are subjected to many threats that can jeopardize confidentiality, availability, or integrity and should be protected with advanced security solutions. Security posture was evaluated with standard benchmarks, CIS control framework or the MITRE framework. Benchmarking enables security program improvement by learning from external organizations. It lets the organization know how its current security state compares to that of other organizations. As an example, the Center for Internet Security, CIS, has created security benchmarks for Azure that map to the CIS control framework. Another reference example is the MITRE attack framework that defines the various adversary tactics and techniques based on real-world observations. Business-critical workloads, which may adversely affect operations if they are compromised or become unavailable, were identified and classified. Enterprise organizations typically have a large application portfolio. Have key business applications been identified and classified? This should include applications that have a high business impact if affected. Examples would be business-critical data, regulated data, or business-critical availability. These applications also might include applications which have a high exposure to attack, such as public-facing websites, which are key to organizational success. Or you could choose none of the above. Now let's look at how your security is validated and how you're handling incident response. So how is security validated and how do you handle incident response when breach happens? And so we'll look at the questions here from the framework as well. You see the first one here for containerized workloads, Azure Defender, Azure Security Center, or other third-party solution is used to scan for vulnerabilities. Sometimes security fails, and it's important to have a clear, solid plan to respond to those. Also, it's important to have a solid security training program for the technical teams to be as competent as possible when the incident happens. To handle incident responses efficiently, businesses should establish a security training program so that technical staff maintains the level of competency required to protect, detect, and respond. They should be able to validate your security defenses by performing penetration testing on workloads. They should also know how to simulate attacks so that they can train others to recognize how an attacker can cause damage. Sometimes security prevention fails. When it does, you can have your Security Operations Center or your SOC review a predefined playbook to help understand, investigate, and respond to security incidents. The procedures in the playbook should be as automated as possible. Automation reduces overhead and can ensure the process steps are done quickly, consistently, and according to your requirements. If prevention fails and security of the application is breached, proper response and mitigation can minimize damage and contain the attacker within minimal boundaries. For containerized workloads, Azure Defender, Azure Security Center, or other third-party solutions is used to scan for vulnerabilities. That's our first question. You answer this based on Azure Security Center is the Azure native solution for securing containers. Security Center can protect virtual machines that are running Docker, Azure Kubernetes, service clusters, Azure Container Registries. ASC is able to scan container images and identify security issues or provide real-time threat detection for containerized environments. Our second question is around penetration testing. Penetration testing is performed in-house or a third-party entity performs penetration testing of this workload to validate the current security defenses. Real-world validation of security defenses is critical to validate a defense strategy and implementation. Penetration tests or red team programs can be used to simulate either one-time or persistent threats against an organization to validate defenses that have been put into place to protect organizational resources. Simulated attacks on users of this workload, such as phishing campaigns, are carried out regularly. That's our third question. People are a critical part of your defense, especially those with elevated permissions, so ensuring they have the knowledge and skills to avoid and resist attacks will reduce your overall organizational risk. Simulating attacks for educational purposes helps to enforce understanding of the various means that an attacker may use to compromise accounts. Tools such as Office 365 attack simulation or similar may be used. Have operational processes for incident responses been defined and tested for this workload? Actions executed during an incident and response investigation could impact application availability or performance. It is recommended to define these processes and align them with the responsible and, in most cases, central SecOps team. The impact of such an investigation on the application has to be analyzed. Playbooks are built to help incident responders quickly understand the workload and components to mitigate an attack and do an investigation. Incident responders are part of a central SecOps team and need to understand security insights of an application. Playbooks can help to understand the security concepts and cover the typical investigation activities. These procedures can and should be automated as much as possible while maintaining confidence and security. Is there a security operations center that leverages a modern security approach? A security operations center has a critical role in limiting the time and access an attacker can get to valuable systems and data. In addition, it provides the vital role of detecting the presence of adversaries, reacting to an alert of suspicious activity, or proactively hunting for anomalous events in the enterprise activity logs. A security training program is developed and maintained to ensure security staff of this workload are well informed and equipped with the appropriate skills. Cybersecurity threats are always evolving, and therefore those responsible for organizational information security require specialized, continual, and relevant training to ensure staff maintains the level of competency required to protect, detect, and respond. Or as always, you can select none of the above for your evaluation. Let's look at how securely you're managing your keys, secrets, and certificates next. It's important to protect secrets such as keys and certificates because they provide access to your workload. You should establish a central SecOps team to provide guidance on how secrets are managed and an application DevOps team to manage the application-related secrets. In addition to keys and certificates, secrets includes tokens and passwords. You can store application secrets in Azure Key Vault. This can greatly reduce the chances that secrets may be accidentally leaked. You can also create and control the encryption keys used to encrypt your data in Key Vault. Remember to track expiration dates of certificates. Secrets, including certificates, should be replaced once they have reached the end of their active lifetime or once they have been compromised. Ideally, the process should be automated and executed without human interaction. Use key rotation in Azure Key Vault to help with this. The types of keys for your workload can go into Key Vault. Access model for workload, secret key rotation procedures are in place. Expiry dates of SSL and TLS certificates, secrets like API keys and certificates are sensitive pieces of information that need to be managed in a secure way. That includes proper storage, encryption, and access control. There's a clear guidance or requirement on what type of keys, whether it be platform or managed keys versus customer managed keys, that should be used for this workload. Different approaches can be used by the workload team. The decisions are often driven by security, compliance, and specific data classification requirements. Understanding these requirements is important to determine which key types are best suitable. Microsoft managed keys or customer managed keys, or bring your own key. Are your passwords and secrets managed outside of application artifacts using tools like Azure Key Vault? API keys, database connection string, and passwords need to be stored in a secure store and not within the application code or configuration. This simplifies operational tasks like key rotation as well as improving overall security. Access model for keys and secrets is defined for this workload. Permissions to keys and secrets have to be controlled with an access model. A clear responsibility or role concept for managing keys and secrets is defined for this workload. Central SecOps teams should provide guidance on how keys and secrets are managed. Application DevOps team is responsible to manage the application-related keys and secrets. Is secret key rotation procedures in place? In the situation where a key or secret becomes compromised, it is important to be able to quickly act and generate new versions. Key rotation reduces the attack vectors and should be automated and executed without any human interactions. What about expiry dates of your SSL and TLS certificates? Are they monitored and is there renewal processes in place? Expired SSL and TLS certificates are one of the most common yet avoidable causes of application outages. Even Azure and more recently Microsoft Teams have experienced outages due to expired certificates. You could also select none of the above as we go through the assessment process and answering these questions. In this module, we covered building a comprehensive strategy, assuming zero trust, and leveraging native controls. This concludes Module 2. We will take a quick 10-minute break and start back with Module 3, Performance Efficiency Pillar. Break. Performance efficiency will be our next topic. Let's get started with Module 3. Okay, performance efficiency. This is another one of our pillars in the Azure well-architected framework. With the Azure well-architected framework, You can build workloads with confidence based on proven deep technical guidance that is actionable and simple to use, helping you to identify areas of improvement and where to focus workload optimization efforts. The framework is at the center of an ecosystem of best practices, Azure Advisor, documentation, offers and support from partners, reference architectures, and design principles. The Azure well-architected framework enables you to achieve your business objectives, operationalizing how to design, build, and optimize cloud solutions. The Microsoft Azure well-architected review evaluates workloads with gap analysis and identifies areas of where to focus your optimization efforts. Reference architectures help you to build and deploy any workload to scale and meet your business needs. Design principles based on proven practices and design patterns from successful customer and partner implementations. And then the Microsoft Partner and Service offers support you and help you build effective cloud solutions. With a good idea now of what the Microsoft Azure well-architected framework means, let's dive into the framework. Performance efficiency offers you guidelines to design and manage workloads that scale according to load changes, as well as design efficient systems, monitor processes, and optimize resources. Performance efficiency focuses on built-in tools in Azure to improve your workload performance and improve your application management. Efficient architecture trade-offs, you want to design parts of the process to be discrete and decomposable to maximize compute resources and take microservices architecture into account. Looking at the tools to provide scalability, you want to manage your resource scaling with Azure SQL Database and Azure App Services, or scale dynamically with demand with Azure Autoscale. You can also optimize your network and storage with Azure Cosmos DB, Azure Traffic Manager, and Azure Cache for Redis for storing state. Active response to performance issues. Identify and remediate potential risk and bottlenecks with your applications with analytical tools that provide data from different layers of your system. For us, we have Azure Monitor, where we can evaluate the health levels of our workloads. We have Log Analytics to provision resources dynamically and scale to match demand. We can also use Azure Application Insights. This can assess and remediate deep application performance issues and trends. And also, you want to think about embracing a data-driven culture to deliver timely insights across data to your entire organization. Optimal service execution, you want to review availability and operation of resources to facilitate network and storage optimization and ensure high-quality service to end users. Efficient trade-offs with applications. Build and develop your applications with tools that facilitate efficient trade-off choices between performance and the other well-architected framework pillars. Now let's look at these principles in more detail. The first principle here, invest in capacity planning. Load testing in pre-production provides insights and evidence on how your workload will perform at various scales, predicting when and how it could fail, so you can identify and fix errors. Load testing helps ensure that your application can scale and does not go down during peak traffic. Load test each application so that you can understand how it performs at various scales. You want to set up baselines that help to establish the current efficiency of your application and its supporting infrastructure. Baselines can provide a good bearing for improvements in your application's performance and helps you determine if the application is meeting its business KPIs. Baselines can be created for any application, regardless of its maturity, a new project, or an application that has been running in production for years. No matter when you establish the baseline, performance during continued development can be continuously measured against it. When code and or infrastructure changes, the effect on performance can be actively measured. Besides standard performance testing and the constant measurements against your baselines, there are two additional flavors of testing: load and stress testing. Load and stress testing measures your application's performance under predetermined amounts of load. Stress testing measures the maximum load your application and its infrastructure can support before it buckles. Load testing takes place in stages of load. These stages are usually measured by virtual users or simulated requests, and the stages happen over given intervals. Load testing provides insights into how and when your application needs to scale in order to continue to meet your SLA. To your customers, whether internal or external, load testing can also be useful for determining latency across distributed applications and microservices. Bottlenecks. Bottlenecks are areas within your application that can hinder performance, and the bottleneck typically worsens as load increases. Bottlenecks can be the result of deficiencies in code or misconfiguration of a service. The first step for determining options for improvements is to ensure that you are capturing telemetry throughout your application. Application Insights provides some great telemetry right out of the box, and you can customize what is captured for even greater visibility. Next, you may want to compare your code to proven architectures in the cloud design patterns. By referencing design patterns, you can avoid common mistakes by developers who are deploying applications into the cloud. And finally, you may consider other Azure services that may be more appropriate for your objectives. While Azure has many services that seem to overlap in capabilities, often there are specific use cases for which the services are designed. Loads can be impacted by world events, such as political, economic, or weather changes, by marketing initiatives, such as sales or promotions, or by seasonal events, such as holidays. You should test variations of load prior to events, including unexpected ones, to ensure that your application can scale. Additionally, you should ensure that all regions can adequately scale to support total load should one region fail. Now, cost can be an additional factor in performance efficiency. You got to balance that. But greater costs don't necessarily always mean increased performance. When observing how close your application comes to meeting business KPIs, you must consider how much improvement will be realized in the application if costs are increased. Then you must evaluate if the cost benefit is worth the investment. Sometimes, small changes in the application logic, caching, or adding an index to a database can dramatically improve performance while not affecting cost whatsoever. Certain improvements can even help reduce cost. Next, let's look at how distributed architectures impact the performance of your application. Distributed architectures are complex and can require many areas of expertise, and as much telemetry captured throughout the application and across all services as possible. To adequately monitor performance across distributed architectures is critical to capture as much telemetry as possible in the application and across services. Your team should be equipped with the necessary expertise to troubleshoot all services in your architecture. On occasion, it may be advantageous to use one service over another simply because your team is better equipped to support it. Then, as your team expertise grows, you can incorporate other technologies. Let's talk about scale. For distributed applications, required effort for ensuring performance efficiency is increased exponentially. You must consider each application, its supporting service, and the latency between all application layers. Anti-patterns. A performance anti-pattern is a common practice that is likely to cause scalability problems when an application is under pressure. For example, you can have an application that behaves as expected during performance testing. However, when it is released to production and starts to handle live workloads, performance decreases. Scalability problems, such as rejecting user requests, stalling, or throwing exceptions may arise. What about fault handling? Resiliency plays a huge role in performance efficiency, as the failure of any service may impact your application's ability to meet your business's KPIs, or worse, scale to meet current load. Chaos testing. The introduction of random failures within your infrastructure against your application can help determine how well your application continues to perform under varying stages of load. Let's take a look at monitoring strategies and some of the monitoring tools that are available in Azure. Looking at active response to performance issues. The principle here is continuously monitor the application and supporting infrastructure. You want to define a comprehensive monitoring strategy to consider scalability, resiliency, and performance. Use application telemetry and profiling to better identify issues, and Azure Data Explorer and Grafana to identify performance trends captured over time. Lack of monitoring new services and the health of current workloads are major inhibitors of workload quality. The overall monitoring strategy should consider not only scalability, but resiliency in terms of infrastructure, application, and dependent services, and application performance as well. For purposes of scalability, looking at the metrics would allow you to provision resources. dynamically and scale with demand. Performance testing should always be based on data captured from repeatable processes in order to understand how an application's performance is affected by code and infrastructure changes. Data must be kept and monitored. Additionally, it is important to understand how performance has changed over time, not just compared to the last measurement taken. It is often helpful to store such data in a time series database and then view the data from an operational dashboard. An Azure Data Explorer cluster is a powerful time series database that can store any schema of data, including performance test metrics. Grafana, an open source platform for observability dashboards, can then be leveraged to query your Azure data. Explore a cluster to view performance trends in your application. Troubleshooting an application's performance requires continuous monitoring and reliable investigation. Issues in performance can arise from database queries, connectivity between services, under-provisioned resources, or memory leaks in code. Application telemetry and profiling can be useful tools for troubleshooting your application. Additionally, network traffic capturing tools such as Azure Network Watcher can be extremely helpful. Resolving performance issues requires time and patience, not just in discovery and investigation, but also in resolution. Code enhancements may be accomplished by deploying a new build, but enhancements to infrastructure may involve many teams. Some services may require updated configurations, while others may need to be deprecated in favor of more appropriate solutions. Regardless, it is critical that you understand the scope of your planned resolution so that all necessary stakeholders are informed. Now that we've covered the key tenets of performance efficiency, let's talk about the next steps. Scaling. And here we have a scaling design checklist. Scaling allows applications to react to variable load. By increasing and decreasing the number of instances of roles, queues, and other services they use. The application must be designed with this in mind. If you require all services to communicate through stateless operations, it prevents the addition or removal of specific instances from adversely affecting current users. You should also implement configuration, auto detection, or load balancing so that as services are added or removed, the application can perform the necessary routing to ensure new app services are put in rotation or removed appropriately. Add reactive auto scaling to the rules where appropriate to cope with new changes, scaling up or down in demand. You can use schedule scaling rules where possible to ensure resources are available without a startup delay. Adding X number of web and worker roles might require Y number of additional queues and Z number of storage accounts to handle the additional workload generated by the roles. So a scale unit could consist of X web and worker roles, Y queues, and Z storage accounts. Design the application so that it's easily scaled by adding one or more scale units. Partitioning allows you to increase scaling by adding more services, whether they be workers, app services, queues, or databases. Design parts of the process to be discrete and decomposable. Minimize the size of each part. Divide the data across multiple databases and database servers, or design the application to use storage services that can provide this partitioning transparently. Use worker roles or background jobs, depending on the hosting platform, to execute a service expected to take a long time to run or absorb considerable resources. A shared nothing architecture uses independent, self-sufficient nodes that have no single point of contention and can, in theory, scale almost indefinitely. Consider utilizing eventual consistency where it is ideal for situations where the same data is read frequently but written infrequently. It improves scalability by reducing or removing the time needed to synchronize related data partition across multiple stores. The cost is that data is not always consistent when it is read, and some write operations may cause conflicts. Caching should occur at all levels where appropriate in each layer of the application, including data access and user interface generation. Let's look at performance efficiency within the Azure well-architected review. The well-architected review provides technical guidance, using direct questions to assess your workload's architecture and capabilities, guiding the next steps towards improving your workload's quality. It's very important that you sign in with your Azure portal information to save and track your progress, and to incorporate any recommendations already available in Azure Advisor to have a complete view of all the areas you can improve. to reach your goal of attaining a well-architected workload. Let's look at performance efficiency questions next. Here are the questions for performance efficiency in the well-architected review. I have selected 3 to walk you through during the session to show how it's done, what's needed to answer them, and to receive the proper guidance. There are 11 questions in the performance efficiency, and all of them are important. We're just choosing a sample here for reference. At any point, you may click on View Guidance, and that will bring you to the report with the recommendations and guidance based on your responses and the information imported from Azure Advisor. Let's walk through each of these questions for performance efficiency. Designing for efficiency has many areas to consider, all relevant and important to ensure the workload is performing as expected. As traffic fluctuates into your application, the amount of underlying resources that you need will vary over time. So looking at this question here, what design considerations have you made for performance efficiency in your workload? We want to look at these questions and see why we want to do some of these activities that are mentioned so that we can be well architected. So the first one here, the workload is deployed across multiple regions. Multiple regions should be used for failover purposes. In a disaster state, as part of either redeployment, warm spare active passive, or hot spare active strategies. Additional costs need to be taken into consideration, mostly from compute, data, and networking perspectives, but also services like Azure Site Recovery. The next question, regions were chosen based on location, proximity to users, and resource type availability. Not only is it important to utilize regions close to your audience, but it is equally important to choose regions that offer the SKUs that will support your future growth. Not all regions share the same parity when it comes to product SKUs. Paired regions are used appropriately. Paired regions exist within the same geography and provide native replication features for recovery purposes, such as geo-redundant storage or GRS. Asynchronous replication. In the event of planned maintenance, updates to a region will be performed sequentially only. You have ensured that both or all regions in use have the same performance and scale SKUs that are currently leveraged in the primary region. When planning for scale and efficiency, it is important that regions are not only paired, but homogeneous in their service offerings. Additionally, you should make sure that if one region fails, the second region can scale appropriately to sufficiently handle the influx of additional user requests. Within a region, the application architecture is designed to use availability zones. Availability zones can be used to optimize application availability within a region by providing data center level fault tolerance. However, the application architecture must not share dependencies between zones to use them effectively. It is also important to note that availability zones may introduce performance and cost considerations for applications which are extremely chatty across zones, given the implied physical separation between each zone and interzone bandwidth charges. The application is implemented with strategies for resiliency and self-healing. Strategies for resiliency and self-healing include retrying transient failures and failing over to a secondary instance or even another region. Component proximity is considered for application performance reasons. If all or part of the application is highly sensitive to latency, it may mandate component co-locality, which can limit the applicability of multi-region and multi-zone strategies. The application can operate with reduced functionality or degraded performance in the case of an outage. Avoiding failure is impossible in the public cloud, and as a result, application require resilience to respond to outages and deliver reliability. The application should therefore be designed to operate even when impacted by regional, zonal, service, or component failures across critical application scenarios and functionality. You choose appropriate data stores for the workload during the application design. Your application will most likely require more than one type of data store, depending on business requirements. Choosing the right mix and correct implementation is extremely important for optimizing application performance. Your application is using a microservice architecture. As compared to a monolithic architecture, an application that is tightly coupled with synchronous communication and often a single data store, microservices leverage concepts such as asynchronous communication, service discovery, various resiliency strategies, and each service has its own data store. You understand where state will be stored for the workload. Stateless services and processes can easily be hosted across multiple compute instances to meet scale demands, as well as helping to reduce complexity and ensure high cacheability. Let's look at how you're modeling the health of your workload. How have you modeled the health of your workload? To build a robust application health model, it is vital that application and resource level data be correlated and evaluated together to optimize detection of issues and troubleshooting of detected issues. Let's look at the questions. Application and resource level logs are aggregated in a single data sync or able to be cross-queried. To build a robust application health model, it is vital that application and resource level data be correlated and evaluated together to optimize the detection of issues and troubleshooting of detected issues. A health model is used to qualify what healthy and unhealthy states represent for the application. A holistic application health model should be used to quantify what healthy and unhealthy states represent across all application components. It is highly recommended that a traffic light model be used to indicate a green healthy state when key non-functional requirements and targets are fully satisfied and resources are optimally utilized. In other words, 95% of requests are processed in less than 500 milliseconds with an Azure Kubernetes service node utilization at X%. Critical system flows are used to inform the health model. The health model should be able to surface the respective health of critical system flows or key subsystems to ensure appropriate operational prioritizations is applied. For example, the health model should be able to represent the current state of the user login transaction flow. The health model can distinguish between transient and non-transient faults. That's our next question. The health model should clearly distinguish between expected transient but recoverable failures and a true disaster state. The health model can determine if the workload is performing at the expected targets. The health model should have the ability to evaluate application performance as a part of the application's overall health state. Retention times for logs and metrics have been defined and housekeeping mechanisms are configured. Clear retention times should be defined to allow for suitable historic analysis, but also control storage costs. Suitable housekeeping tasks should also be used to archive data to cheaper storage or aggregate data for long-term trend analysis. Long-term trends are analyzed to predict performances before they occur. Analytics can and should be performed across long-term operational data to help inform on the history of application performance and detect if there have been any regressions. For instance, if the average response times have been slowly increasing over time and getting closer to maximum target, consider scaling up your infrastructure. And that was our last question. If you haven't done any of this, you can click none of the above. Let's look at how you're benchmarking your workload. How are you benchmarking your workload? Have you identified goals or a baseline for workload performance? Identifying benchmarks for workloads is a best practice that will help you monitor and keep your workload performance in line with expectations. Benchmarking lets you know how your current security state compares to that of other organizations. Next question. Performance goals are based on device and/or connectivity type as appropriate. There are many types of goals when determining baselines for application performance. Perhaps baselines can center around a certain number of visitors within a given time period, the time it takes to render a page, the type required for executing a stored procedure, or a desired number of transactions if your site conducts some type of e-commerce. It is important to identify and maintain a shared understanding of these baselines so that you can architect a system that meets them. Performance goals are based on device and/or connectivity type as appropriate. It is important to identify how users are connecting to your application. Are they primarily connecting via a wired connection, wireless, or by using a mobile device? Additionally, you should seek to understand the targeted device types, whether that be a mobile device, a tablet, or a laptop or desktop PC. You have identified an initial connection goal for your workload. It would be helpful to determine a goal that is based upon from when the connection reaches the server to when the server spins or cycles up to provide a response. By establishing this baseline, you and your customer can determine if adequate resources have been assigned to the machine. These resources can include, but are not limited to, processors, RAM, and disk IOPS. Finally, creating rules for always on or properly configuring idle timeouts, in other words, IIS, containers, etc., would be especially helpful for optimizing response times. Is there a goal defined for complete page load times? What are your goals for a completed page load? When formulating this metric, it is important to note the varying thresholds that can be deemed acceptable. Some companies whose primary audience is internal, and they are salary-based, may base their thresholds on the user's mental capacity to sit at the application screen. Other customers that have service-related users, in other words, users who are paid for performance, may base their thresholds on the ability to keep the user working as fast as possible. Mental state is not the primary motivator, because increased productivity typically means increases in revenue. You have defined goals for an API service endpoint, complete response. Data-centric applications are comprised of pulling data from various API endpoints. For a single page, this could mean many server requests. The page is only as fast as the slowest endpoint. It is important for you to test the performance of your APIs to quickly identify bottlenecks in the application that impede user experience. Here's our next question. Are there goals defined for server response time? Similar to previous questions regarding the initial connection to a service, you will also want to understand how long it takes for the server to receive, process, and then return that data. This round trip can also help ensure that enough hardware resources have been assigned to the environment. Additionally, it is possible to identify noisy neighbors, applications running on the same disk, typically in a virtualized environment, or sharing the same network that are consuming available resources. You have goals for latency between the systems and microservices of your workload. Performance should not only be monitored within the application itself, but response times between service tiers should also be noted. While this is important for interior applications, it is especially crucial for microservices. Most microservices leverage some type of pub-sub architecture where communication is asynchronous. However, validation for sending and receiving messages should still take place. In these instances, understanding the routing and latency between services is imperative to improving performance. There are goals on database query efficiency. Ensuring the data operations are optimized is a key component to any performance assessment. It is important to understand what data is being queried and when. The data lifecycle, if abused, can adversely affect the performance of any application or microservice. Confirm that a database administrator, a data architect is preferred is part of the assessment, as they will have the necessary tools for monitoring and optimizing a database and its queries. You have a methodology to determine what acceptable performance is. There's almost no limit to how much an application can be performance tuned. How do you know when you have tuned an application enough? It really comes down to the 80-20 rule. Generally, 80% of the application can be optimized by focusing on just 20%. While you can continue optimizing certain elements of the application, after optimizing the initial 20%, a company typically sees a diminishing return on any further optimization. And if you haven't done any of these, you can click none of the above. This concludes part one of our session. Let us recap all the content that you have seen thus far. We talked about the well-architected framework, what it offers you, the well-architected review guide, as well as how you can answer questions across the different pillars. We then looked at security and looked at all the ways you can design a comprehensive strategy for making sure your workloads are secure. And then we wrapped up with performance efficiency, making sure all of your workloads are running optimally and you're not underutilizing or overutilizing any resources. Thank you for your attendance so far, and we look forward to seeing you next time for part two of this Microsoft Azure Virtual Training Day Well-Architected Framework. Now let's open the floor for questions.